Oh, I have the mute on. Here we go. I started teaching physics a while ago, about 17 years ago. And when I started out teaching math, which is why my website is pitmath.com. When I started teaching physics, my mom asked me a question. She said, Kelvin, I know what math is. What the heck is physics? And a lot of you have signed up for Physics 11 and you're going, I don't know what physics really is. I'm going to give you a definition that my physics prof gave me. My physics prof said that physics was the science of measurement. Now, that's a very broad definition because it means anytime you're collecting data, you're doing physics, which means it swallows up biology and chemistry and earth science. And it means that physics is everything. So I kind of like the definition. It's a bit of an arrogant definition, but it leads to a question. Okay, if it's the science of measurement, then Tito, what the heck do we measure? There are 7 fundamental things, but here are the big 3 that we'll be doing mostly this year. One of the ones we're going to talk about is time. Does anybody know what do we measure time in science? What are the fundamental units for time? I'll give you a hint. It's not hours, not minutes. Seconds. Another thing that we're going to measure is length. Does anybody know what the SI, Standard International Unit for length in science is? Not feet, sorry Americans. Nope. Meters. And you can spell it ER or RE. I think the Brits spell it RE, whichever. Take both. And the third one is mass. Do we know what the fundamental units for mass are? Loud and proud. It is kilograms. Elias, learning names. You are correct. It should be grams because all of the other fundamental units don't have a metric prefix like centi or kilo or giga. But a gram was so small, we settled on the kilogram just because it's much more mathematically convenient. So you'll notice we're going to look at the 7 fundamental units. It's the only one that has the metric prefix. And I'm going to pretend that you know the abbreviation. I tend to abbreviate. See how I did that? I abbreviated it. Nothing. Okay. The units used are the SI units. It's the Système International, the French. This is the fundamental. It's sort of the metric system, but it's the science version of the metric system. The base quantities are, so we have length, which was meters, lowercase m is the abbreviation. Time, which is seconds, lowercase s is the abbreviation. Mass, which is kilograms, kgs. And then there are 4 more. These 7 units are the ones that we have defined. Every other unit you learn in science is based on some version of these 7. So for example, when you learn what a Newton is, you'll learn that it's actually a kilogram meter per second squared. It's made up of those 3. When you learn what momentum is measured in, you'll learn it's kilogram meters per second. You'll learn that velocity is meters per second. You'll learn that they're all made. You'll learn that a joule is a Newton meter, which means it's a kilogram meter per second squared meter. They're all made up of these 7 units. And so my question is, does anybody know what the fundamental unit for electric current is? If you had a Science 9 teacher who did a whole bunch of stuff on circuitry because he was really, really enthusiastic, your Science 9 teacher might expect you to remember what we measure current in. It's not volts. By the way, volts measure voltage, which is a dumb, fairly easy way to remember that. Joules measures energy. Ohms measures resistance. Amps. Named after a scientist whose last name was Ampere, symbol capital A. You're going to find, by the way, we're going to run into our problem because our English alphabet only has 26 letters. And so context is going to be everything. If you see A equals, that A stands for area. If you see that A stands for amps because it came after a number. The really tricky one is the letter W. If you see W equals, that's work. If you see a W after number, that's watts. If you see a W after an at symbol, that's west. And there's a problem also with north, because N is newtons, N is north, and N is normal force. We need more letters in our alphabet. We don't have more letters in our alphabet. So you're going to find there's a really good shorthand that we use in physics, but context is everything. Amps. Temperature. What? What? So my first name is Kelvin. I happen to be an SI fundamental unit. That's a lovely coincidence for a physics teacher. It's degrees Kelvin, and the abbreviation is degrees and a lowercase k. That's where the term absolute zero comes from. Absolute zero is 0 degrees K. And that's, in theory, when you've removed all of the energy from the molecules or the atoms so that they no longer vibrate at all. And so because you can no longer remove any energy from them, in theory, that's as cold as things can get. Or is it? Maybe not, but that's another nerd trivia tangent. The amount of a substance, you'll do this one in chemistry. Starts with the letter M. Moles. And you'll learn about Avogadro's number. 6 point something something times 10 to the something something. The last one is kind of my favorite one because for these 6, unless you know what they are, you can't tell how big one is. In other words, you've grown up and so you know that a second is about that long. But unless you've grown up, you have no way of knowing that's how long a second is unless you've grown up in a culture where we use seconds. You know that a meter is about this big because you've seen meter sticks. The unit for light intensity I like because as soon as I tell you the name, you'll know how big one is. The unit for light intensity is candles. And one candle is exactly as big as you're thinking right now. Yeah, that bright. Yeah, okay, that bright. It's actually candelas, so I'm going to cheat a little bit. So it's C-A-N-D-E-L-A, abbreviation C-A. And then if you would be so kind as to put a little arrow right after kilograms. Those 4 below, although I'm a nerd and I've told you about them, we won't be looking at this year at all. We'll be doing everything with meters and seconds and kilograms and building on those. In Physics 12, we'll get to there. We'll bring in electricity and magnetism, which allows us to do that. But I got to be honest, we don't do heat and temperature in Physics 11 or Physics 12. You'll do moles in chemistry. We don't do light intensity, although it's really cool. For Elias, if we're talking about degrees Kelvin, here's a handy way to tell them apart. So on the Fahrenheit scale, 0 degrees is really cold outside, 100 degrees is really hot outside. On the Celsius scale, 0 degrees is fairly cold outside, 100 degrees, you're dead. And on the Kelvin scale, 0 degrees, you're dead, 100 degrees, you're dead. So there's an easy way to kind of compare the 3 of them, okay? Turn the page. In addition to the base units, grams, joules, newtons, the SI system uses a prefix system that involves powers of 10. You may call it the metric system, but it's really the SI system. Prefixes can be placed in front of a base unit, and they represent a multiplying factor. For example, 2.5 kilograms. Kilo is really the same as 10 to the 3. It can be replaced with 2.5 times 10 to the 3 grams. Now, if I was a bad teacher, I'd make you memorize all of these. Hey, look at the back of your green sheet, please. Please tell me I put these all in a chart somewhere. So you might memorize some because you're lazy and you get sick of looking them up. And I gotta be honest, that's the only reason you should ever memorize anything. Because you're lazy and you get sick of looking it up. I have no use for teachers that just make you memorize crap that you can look up. So I will not make you memorize useless stuff. Once in a while, I'll make you memorize something that's really, really handy. Or once in a while, you'll hear me say, although this one is on your formula sheet, you're going to be using it 600 times in the next 3 weeks. It's worth memorizing because you are going to get sick of looking it up. But otherwise, you have all your prefixes there. So the prefix kilo means times by 1,000 or by 10 to the third. We have a chart here. So in the middle where it says base unit, that would be grams or meters or seconds or joules or watts or newtons or whatever unit we're dealing with. We have the 7 fundamental ones. Joules and watts are based on those 7 fundamental ones, but there are more units out there. And if you want me to put a power of 10, we would say it's 10 to the 0, because what's anything to the 0 power? Not 0. What's anything to the 0 power actually? 1, so whatever. Let's get smaller. Deci. What's the symbol from your green sheet for deci? Not deca, but deci. Just a lowercase, uppercase, it makes a difference. Lowercase d, and that's multiplying by 10 to the what? -1, it's also the same as dividing by 10. So if you ever see a lowercase d in front of a number and you want to convert it to its base unit, you just multiply it by 10 to the power of -1. Centi, many of you are familiar with. Now you're going to say, Mr. Dueck, I know there's 100 centimeters in a meter. Doesn't that mean I times by 100? No, it means if you start with a meter and you go to centimeters, you're dividing a meter into 100 chunks. So centi, that one I know is lowercase c, yes? And it's times by 10 to the -2 or divide by 100. Here we're going to run into our first problem of using the same letter, because a lowercase m by itself is meters, but what's the abbreviation for milli? Lowercase m. So if you see a lowercase m in front of another letter, that's milli. 10 to the -3, yes? So a millisecond is 1/1000th of a second. If you take 1 second and you divide it into 1,000 chunks, that's a millisecond. We can't use m for micro because we already used m for milli. So we're going to use a Greek letter. And the Greek letter looks like this. In fact, I can tell you what the Greek letter looks like. Looks like this. The Greek letter mu. What does a Greek cow say? Mew. What does a Greek cat say? Mew. There's all sorts of dumb jokes to go with it. But that is the symbol for micro. That one you'll probably memorize in grade 12, because when we start looking at electricity, we deal with everything in microcoulombs, because 1 coulomb would fry you, would cause you to burst into flame and kill you. A microcoulomb is a much nicer charge to deal with. So micro, 10 to the -6, yes? And then there's nano, which is lowercase n. And now we start to go up by powers of 3. We're moving over in the same way in our number system. Every time you add 3 zeros, you go from thousands to millions to billions to trillions. In the small direction, we're doing the same thing. So we have pico, which I know is a lowercase p. Oh, sorry, nano is 10 to the -9, yes? I used to stop there. When I started teaching physics in 2002, that was the cutting edge. Stuff wasn't smaller than that. And then a few years later, I had to add pico, which is lowercase p, 10 to the -12, and I used to stop there. But I will show you later today or some other time a femto camera, a camera that takes a picture, a movie in a femtosecond, and that movie is so short, you'll actually see a beam of light moving across the screen. Honest. So femto was lowercase f, and that's 10 to the -15, yes? Atto is lowercase a, 10 to the -18, which is crazy small. I've stopped there. Who knows, 5 or 6 years from now, I may need to extend it. Let's go bigger. So back to our base unit. We have deca. Now, deca can't be a lowercase d because that was taken by deci. What the heck is deca? lowercase da. That's a stupid one. Now, I got to be honest, by the way, these two I never use. I will never say 1 decameter. I'll say 0.1 meters because that makes more sense to me. And I will never say, oh, that's 1 decajoule, 10 joules. Because, sorry, decajoule. Decimeter will be 0.1 meters. Decajoule will be 10 joules. That makes more sense to me. So those two I hardly ever use. And I hardly ever use centi and hecto. I would rather say 0.03 meters. I can think that number okay. Or I would rather say 300 joules. I can think that number okay. Numbers that get bigger and smaller than that, I use the prefixes. So deca, what was it, DA? And that's times by 10 to the positive 1. And hecto, is it just H or is it HA? Lowercase? 10 to the 2. Hardly ever use that one. Kilo, this one I have memorized because I have a driver's license. And so when I see road signs, I know that 1 kilometer is 1,000 meters because often for the on-ramp or off-ramp, it'll say 800 meters or 0.8 kilometers away. So kilo I have memorized. Lowercase k is 10 to the 3rd or 1,000. I used to stop when I first started teaching at mega. My first hard drive was 8 megabytes. And I remember thinking, how will I ever fill 8 megabytes of data? That's ridiculously huge. I mean, I'm saving everything for the rest of my life. Mega, capital M, yes? And it's 10 to the 6th. This one I have memorized because of the stupid lottery. There's the lottery called Mega Millions. And so I know mega is times by 1,000,000. And I happen to know that 1,000,000 is 10 to the 6th. I didn't try to memorize it, but I just have. And then all of a sudden we started talking about memory in gigs, in giga, which was capital G. And that's 10 to the, now we start to go up by 3s again. Yes, 10 to the 9th, I believe. And I brought in Tera about 8 years ago. This is a 1 terabyte hard drive, and I have on order, it's going to arrive today from Amazon, a 4 terabyte hard drive, because this is getting full, because I make all these video lessons and they take up room, and I do save them as backups or whatever. So, okay, so I have bumped up to Tera, which is 10 to the 12th. And then all of a sudden, Google started talking about having petabytes of data. So I had to bring in peta, which is capital P, 10 to the 15th. And then X, capital E. How far did I go on your green sheet, by the way? Did I go the same distance as this chart here, too? Yeah. Okay. Capital E. So you don't need to memorize any of these. You just need to know that they're on your green sheet, and you can look them up. But if you're lazy, you'll memorize some of the common ones because you get sick of looking them up. Go ahead. Any base unit can be used with a prefix. For example, 1 kilogram, I would say to myself, well, 1 kilo is the same as times 10 to the 3, and I might even dare to do that in my head because I know that 10 to the 3 is 1,000, and so I would say, oh, hey, that's 1,000 grams. 1 kilometer is 1,000 meters. Or if I'm going this way, I would say centimeter, that's times 10 to the negative 2, which is the same as dividing by 100, or you could do it on your calculator, and I would get, okay, that's 1 cent, sorry, I want to go this way. 100 centimeters is 1 meter. I would replace the centi with a times 10 to the negative 2. We're going to do a whole lesson on unit conversion. I'm going to give you a way that works for me, but I'm also going to say to you, if you have your own method for converting from one unit to another unit and it works for you, I don't care how you do it as long as you get the right answer, go ahead. But I'm going to give you a method that isn't the easiest method, but it's the one-size-fits-all and requires me not to memorize anything method. And I'm willing to learn a slightly more difficult method if it doesn't require me to memorize anything, because I'm naturally lazy. So there. Put your pencils down.